Good morning, dear colleagues. Let me present the topic of our research, augmented reality while studying radiochemistry for incoming chemistry teachers. Comprehensive involvement of information and communication technologies within the study process and within managing of education system and the education establishment is the main way to supply effectives of education reform. Applying the IKT into whole education system will definitely expand the teacher's possibilities, set up the teacher-student cooperation, build the student technical skills, which are so important for our century. Nowadays, children are getting used to availability of data wherever they are 24 hours per day, 7 days a week. They are also getting used to the virtual reality. That's why the so-called smart education, which requires the use of smartphone, tablets, interactive boards and other devices with internet access, is becoming more and more popular. The integration of the study process with mobile devices and computers, uniting the real objects with the virtual ones, supplying the necessary information about the study's objects, including their three-dimensional visualization, becomes possible with augmented reality. Chemistry is considered to be a complicated science. It operates with the ideas that cannot be understood intermediately and require specific images and associations in the student mind. The controversy of the 2D images lead to the important ideas not received properly. The problems of space visualization, which are easily resolved with tools like turning around the structure and analyzing the symmetric characteristics, are almost non-resolvable with 2D even for competent students. What even more, a lot of students are visuals. This means they can memorize an object and they saw in a better way comparing with one they imagine with two-dimensional pictures, teacher's lecture or the paragraph they read in the school book. The objective of research is developing a mobile application designed to visualize basic definitions of discipline radiochemistry and radioecology in 3D. They can be used by the teachers and the students in order to study the education material effectively. AR markers were developed. 3D models of nucleus fundamental parts as well as animation designed to explain the nature of nuclear reaction were developed for the mobile application. And the study material was presented as mini outline. The main features of augmented reality are integration of both real and virtual objects in the natural environment, real-time operation practice, interactivity, equalizing the specific of real and virtual objects. The definition of role zoomer of the augmented reality is one of the types of virtual environment that augments the external reality but does not totally change it. Augmented reality allows the user to see the real world when virtual objects are either laid over the real world or consolidate with each other. The augmenters can help the human to focus on certain elements of the image from the camera, increases understanding of the object around by means of supplying the appropriate information that is laid on the image with the next message of the visual image. Within the education sphere, augmented reality helps students discover the world, because they can point the camera on the marker image and get a lot more interesting information than the two-dimensional pixel of the school book or textbook. This augmenter may contain a 3D model in the object, animation with some explanation, or a certain mechanism of phenomena, a video manual about an experiment, etc. The developed mobile application contains the study material of the discipline radiochemistry and radioecology, linked by the students of the specialty general education chemistry of Vasily Stefanik Prokopyevsky National University during the first year of study and is one of the imperative disciplines. The discipline supplies the basic of ecology competencies and key principles of green chemistry. Learning this subject requires introduction with phenomena of radionuclide, radioisotope, the nucleus, the fundamental particle, etc. Most of these definitions are mostly imaginary for the student to not have a live visual recognition. Phenomena of nuclear fission and radioactive decay are imaginary as well. Unfortunately, the 2D images of contemporary handbooks of this discipline did not provide the opportunity to visualize the study material in good manner, as well as to supply the exact context of definitions, demonstrate the reaction mechanism, etc. That's why applying the augmented reality is rational for the purpose of visualizing the study material. Applying it allows demonstrated 3D models of nucleus, the fundamental particles, the nature of radioactive decay, nuclear fission, the specific of managing of nuclear weapon. As a result of study, for the purpose of visualizing of study material, a free mobile application called Radiochemistry was developed. It can be downloaded with QR code. Including the mobile application within the study process is designed to visualize the study material, receive short information about the visualized object, and to examine the student's knowledge by means of test control. Augmented reality markers were developed on the platform Vuforia. 3D objects were modeled in the 3D Max. Augmented reality objects were realized with a multi-platform tool designed for development to a three-dimensional mobile application, Unity 3D. The developed mobile application operates in 3 modes: studying the basics of radiochemistry with augmented reality, test control of knowledge, and the vocabulary. While working with the augmented reality mode, the student can look into the external view of the objects and receive short summary about them through a mini outline. While studying the subject, the chain nuclear reaction, the mechanism of nuclear weapon, and the nuclear pile or the nuclear power station are learned theoretically. In this way, studying the education material of this discipline requires a more sophisticated explanation from the teacher and a dynamic dimensional image from the student. This in detailed visualization of the study material makes this process easier. From makers, one can receive information about types and mechanism of nuclear decay, specific of radiation and its correlation with the substance, the nature of chain reaction, principles of nuclear weapon deployment, out of control chain reaction, principles of nuclear weapon deployment, controlled chain reaction. In the cell phone or tablet with the mobile app is pointed of the marker, the image becomes alive in 3-dimensional mode and appears on the screen, and the image can be manipulated in certain ways: turn around, zoom in, view from different angles, in order to better understand its structure, specific, and for animation, the nature of reaction path. Mode number 2, the testing mode, gives students the opportunity to verify their knowledge. The app has selected tests on the topic atomic nucleus, radioactive decay, and nuclear transformation. The tests are classified by 2 complexity levels. 2 variants of enclosed type tasks with 1 correct answer were developed. 10 questions per variant. Mode number 3, the vocabulary, gives the opportunity to learn and revise the basics on the topic atomic nucleus, radioactive decay, and nuclear transformation. This tool of IKT is also crucial in the remote study days, when the classic explanation of the study info are replaced with online lectures, and lack of straight communication with students make it impossible for the teacher to monitor the memorizing the study material. Conclusions. The mobile application was developed for the purpose of visualizing the basics of the Kostiuk, radiochemistry, and radioecology. It can be used by the teachers and the student in order to understand the study material actively. Applying the augmented reality objects give teachers the opportunity to explain the theory, which cannot be illustrated with 2D image appropriately, and to review it live and the students perceive it effectively. Studying the education materials involving AR gives the upcoming teacher the ability not only to perceive the information in good manner as a student, but also build the skill to use it in the future pedagogic work during chemistry lessons, get prepared to discover new education technologies, and learn throughout the lifetime. Applying augmented reality is effective with remote education as far as it solves the problem of demonstrating the studied material and allows the student to receive information anywhere they are. Thank you for your attention.